everyone, this is Jay, your instructor for computer network, and in this session we will discuss the congestion in the network. So let's see first what is congestion. So when the number of packets sent to the network is greater than the capacity of the network, it will create the congestion. So suppose your computer is sending 10 packets per second in a link which could transfer 5 packets per second only. So in that case, the link will be congested very soon and all the remaining packets will be discarded by the link. So sender should be sending packets according to the capacity of the link. So there are many reasons for the congestion, such as the capacity of the link can be lower, or the rate of the sender can be higher, or the intermediate device in the network could be working at very slow speed. The intermediate device in the network is having lesser memory. So these are the causes which creates the congestion. Now let's see, if there is a congestion in the network, so what we could do. So the congestion control is divided into two types, the open loop congestion and the closed loop congestion. The open loop and the closed loop congestion is further divided into further types. So the open loop congestion has different types such as retransmission policy, then window policy, acknowledgement policy, discarding policy, and the admission policy. And the closed loop congestion has different types such as back pressure, choke packet, implicit signaling, and explicit signaling. Let's discuss the open loop congestion first. So the first type in the open loop congestion is the retransmission policy. Now what is the retransmission policy? Retransmission policy tells that when sender needs to retransmit the packet, the rate of the retransmission should be lower. Suppose sender has sent packet and it has not received any acknowledgement yet, and it has wait for very little amount of time, and it concluded that okay, I have not received any acknowledgement, so I'll retransmit the packet again. But because the transmission is very slow, the sender is going to receive the acknowledgement, but it is not waiting that much long and it is retransmitting the packet again. So as it is retransmitting the packet again, it will just add congestion in the network because that packet is transmitted and that packet is unnecessary, right? So these criteria the sender should keep in its mind, that it should not retransmit at very high rate. It should first wait for the acknowledgement, and if acknowledgement is received or if it is not received in stimulated time, so in that case it can retransmit the packet. The second type is the window policy. The window policy tells that the sender's window should be selected according to the capacity of the link. You know that sender could have different size of windows, right? So sender can send 4 packets in second, it can send 8 packets at a time, it can send 16 packets at a time, whatever the capacity of the sender is. But to send the packet that many packets at a time, it should also consider the capacity of the link. What if the link cannot carry more than 5 packets per second or more than 5 packets at a time? So in that case, the remaining packets will be dropped. So window policy tells that the sender should be sending packets according to the capacity of the link or receiver. Then there is acknowledgement policy. Now the acknowledgement can be of two types. Sender can receive acknowledgement for every packet it has sent, or it can receive acknowledgement for, let's say, every 10 packets or every 5 packets. So if sender is receiving acknowledgement for every packet sent, in that case in the link there will be so many packets that will be traveling to and fro between the sender and the receiver. But if sender is receiving acknowledgement for, let's say, per 5 packets, so in that case there will be lesser number of packets which will be traveling in the link. So sender can select any two of the acknowledgement. It can either select every acknowledgement for every packet sent, or it can receive acknowledgement for every 5 packets or 10 packets, and that acknowledgement is called cumulative acknowledgement. Then the next type is the discarding policy. Now what is the meaning of the discarding policy? Suppose router is receiving 10 packets and router now has to decide that which packet goes to which interface, right? That is a function of the router. But now imagine router is receiving more number of packets that is greater than its capacity. Suppose router is now receiving 50 packets and now it has to decide that which packet should be forwarded to which particular link. So in that case, router has to decide that which packet should be forwarded first and which packet should be forwarded last. So discarding policy tells that router will analyze each packet, and after the end, according to the priority, router will select that particular packet will be forwarded first and remaining packet should be forwarded after that. And if some packets are having very lower priority, so in that case router can easily discard those packets. For example, if you are making an audio call with your friend and in the audio transmission some packets are very less sensitive. What I am trying to say is, if some packets in the audio transmission are discarded, so that will not affect so much in the quality of the audio. So if those packets are discarded, so there will be less congestion in the network and more packets can be delivered by other devices. So discarding policy tells that we can discard some less sensitive packets. Then last type is the admission policy. Admission policy tells that router can analyze packets which are having high priority and it can discard some packet or it can delay some packet according to the priority. The second type of the congestion control is the closed loop congestion, and let's discuss the first type in the closed loop congestion, which is back pressure. So as you can see in this figure, there are two devices which are communicating with each other, and there are 4 intermediate devices which you can see on the screen. Now suppose each and every device is working on some particular frequency, and because the device which is colored in brown is working at very slow, so it becomes congested very quickly. So when there is a congestion in the network, so that device will stop receiving any packet from the previous devices. Now when the device which is before the congested device, it receives so many packets, so that device also become congested. So when the device 3 become congested, it stop receiving packets. When device 3 stop receiving any packet, the device 2 become congested because device 2 is not able to forward any packet to device 3. When device 2 become congested because 3 is not receiving, so 1 become very congested. So 1 cannot transfer any data to device 2. And when 1 become congested, the sender gets to know that okay, there is a problem in the network, so sender will wait for some amount of time and after that it will send the packet. And for the next time it is sending the packet, the rate of the packet sent will be much lower. The second type is the choke packet. So in the choke packet, the only difference is that the congested device will generate a particular message and it will send to the source. So in the choke packet, you can see that the device 3 which is congested, it will not stop receiving any packets, but it will inform the sender using a special packet that I am facing congestion, please send the data at slower rate. The next type is the implicit signaling. So in the implicit signaling, there is no communication between the congested node and the source. So source assumes that okay, there might be a possibility that there is a congestion or there could be congestion in the network. So source will send packet at very low rate, or it will send packet after some time. The next type is the explicit signaling. In the explicit signaling, if node experiences congestion, it can explicitly send packet to the source or destination to inform about the congestion. So you might be thinking that this is exactly same as the chalk packet, right? But the only difference between the explicit signaling and the chalk packet is that in the explicit signaling, the signal is including in the packet that carry the data. In the chalk packet, separate different packet was used to inform the sender that there is a congestion. As you can see that there is a device A and host B. So in the very first time, the sender will send as many packets as it wants to send. So in the initial stage, sender will send as many packets it could send, and this phase is known as multiplicative increase. So A will send one packet. After sending one packet, it will wait for acknowledgement. After that, it will send two packets, and after sending two packets, it will wait for acknowledgement. Now if after sending two packets at a time, if sender is receiving acknowledgement in the particular amount of time, it assumes that okay, there is a lesser possibility that there could be congestion in the link, so sender will send more packets. After that, it will send more number of packets, and after that sending, it will wait for acknowledgement. If again acknowledgement are received in particular amount of time, so sender will think that okay, there is a no congestion, so it will send more number of packet. So this phase is known as the multiplicative increase. So sender will keep increasing the number of packets which are sent per second. And if sender is receiving acknowledgement after sending those many packets in particular amount of time, it will keep sending it. But if sender is receiving acknowledgement after some delay, so in that case, sender will think, okay, there is a possibility that there is a congestion in the link. So sender will slow down the rate of sending packets. And that second phase is known as additive increase. So in the additive increase, sender will send one packet at a time. So it will send one packet, it will wait for acknowledgement. If acknowledgement is received, so again it will send one more packet and it will wait for acknowledgement. Then after it will send more packet, it will wait for acknowledgement, and this phase is known as additive increase. So it will send one packet, then two packet, then three. It will send one packet at a time and it will wait for the acknowledgement. And after the additive increase, if sender is receiving no acknowledgement, in that case it will assume that okay, there is a congestion in the link, so all the process will be start from the beginning and it will start from the multiplicative increase. So in the additive increase, if sender is receiving packet after some delay, so there is no problem because sender knows that there is a possibility of the congestion. But in the additive increase, if sender is getting no acknowledgement, so that is a problem, right? So in that case, it will start all the way from the beginning. And this is how the congestion in the TCP work. And also this is the end of the session. So if you have any doubt, you can ask me in the comment section. Thank you so much.